This is the summary for Lesson 8, translating to y equals mx plus b. And this is the key to this lesson, is understanding y equals mx plus b. And we know that m is the slope. We're using the word move for m for slope. Slope is what moves as you look at these relationships. And b is the beginning. It's where it crosses the line. The graph crosses the y-axis to begin the relationship. So b we're using as for the word beginning. So if you have a snowstorm and there are 0 inches of snow when the snow starts to fall, there's 0 inches of snow on the ground when the snow starts to fall. The way to start out with these problems is write down what the properties are. So the two properties that are given to you in this problem are inches and hours. And if you forget what to do, if you write down the properties, then write down the relationship between the properties. You could either write inches per hours, so inches per hour or inches per hours, or hours per inch or hours per inches. Either way works. Now, in this case, it makes more sense to talk about inches per hour. So how much snow fell in an hour. But there are times where you might want to figure out how many hours did it take for an inch of snow to fall. So what were the hours per inch? But in this case, it's inches per hour. And they tell you it's 1/2 of an inch for every hour. So that's your y over x. And so you just have to remember that that's the k value. That's the slope. And it's telling you how many units of change are there in y for every unit x. And there is 1/2 of a unit of change in y for every unit change in x. So y is 1/2 the units of x. So if you go down here to the graph, the change in y, which is 1/2, is 1/2 the units of the change in x. So for 1 unit in x, the change in y is 1/2 of a unit. 1 unit in x, 1/2. 1 unit in x, so 1 hour, 1/2 of an inch. 1 hour, 1/2 of an inch. 1 hour, 1/2 of an inch. Now it tells you every value of x that you choose, the number of inches fallen was going to be 1/2 that number of hours. So in 4 hours, how many inches of snow fell? 2 inches of snow, because 2 is 1/2 of 4. So this y, 2, is equal to 1/2 of the amount of x, which is 4. 1/2 of 4 is 2. This is the y equals x part of the equation that we've talked about previously. This means it's a proportional relationship. So it goes through 0. There's nothing, if it's 0 time, then there are 0 inches of snow on the ground. In this case, the snow is just starting to fall as you're starting to measure it in this problem. So y equals kx. It's proportional to the amount of time that the snow has fallen. So the amount of snow is proportional to the amount of time. If you double the time, if you go from 2 hours to 4 hours, then you're going to double the inches of snow from 1 inch to 2 inches. The other thing to note from this relationship is that the change in x is the x coordinate. So if you go out here, the x coordinate for this point right here is 4. So if you go out here 4 hours, that is the change in x. It would be this x minus 0 is its change. And so it's going out here 4 hours, and the change in y is the coordinate for y. For a proportional relationship, you don't have to subtract anything. Think about this slope triangle. It's right up against 0.00, the origin of the graph. And so the y value for this point, the y coordinate, is 2. So y minus 0 equals 2 units. So the change in y for a proportional relationship is the y coordinate, which in this case is 2. So up here, you would, to write this equation, normally they just say, oh, it's a proportional relationship, just write y over x. Y is equal to y over x, which is k times x. But you can go one better than that. You know a little bit more, that the change in y is y minus 0. The change in x is x minus 0. This is important because we're going to write the equation for a line that's not proportional, that's not a proportional relationship in a moment. So if you understand that that change is you're subtracting 0, so it is the value for y, the y coordinate, and it's the x coordinate. And so y over x equals the slope, which we already figured out, which in this case, for this point, you might write that as 2/4, which is the same as 1/2. So the slope is going to stay the same. And it's telling you that the value of y, the units of y, are 1/2 the number of units of x. And so the equation is y is equal to 1/2 the number of units of x. Y equals 1/2 x. So proportional relationship, start out with the properties, write y over x, and think about this form of the equation, y equals kx. K is the same as y over x. K is the constant of proportionality. I don't think I wrote that anywhere. Take you way back. Constant of proportionality, which for a proportional relationship is the same as the slope of this line. Now, what if there is some snow on the ground already, and then you start graphing the snow after that point? So at 0 time, there's already 5 inches of snow on the ground, but it's falling at the same rate as the storm before. So this is one storm where there's no snow on the ground, and this is the second storm where 5 inches of snow have already fallen and accumulated on the ground, and now more snow is falling, and it's falling at the same rate, 1/2 of an inch every hour. So the properties again are inches and hours, so it's inches per hour, and they tell you it's 1/2 of an inch per hour. So these two lines are going to be parallel. So you're going to translate this line up 5 units from 0 to 5. Every other point is going to translate up 5 units. So this relationship now is y equals kx, y equals 1/2 the units of x, but you also have to add these 5 units that you started with. So you want to calculate what are the total number of inches of snow that have fallen. So in 4 hours, what are the total number of inches that have fallen? Is this point right here, and you read it off the graph, it's 7 inches. That's why this point is 4, 7. But now notice you can't get the slope from just dividing 7 divided by 4 or 6 divided by 2. We'll go into that in just a second. You have to figure out what the change is. The change in x is 2 units, and the change in y, in this case, is 1 unit, and we'll talk about how you figure that out in just a moment. But just notice that this is now y equals mx. M is the slope, 1/2. Think about moving, so you move over 1 hour, up 1/2 of an inch. Move over 1 hour, up 1/2 of an inch. Plus the beginning, plus b, or the beginning amount is 5 inches. So move for slope, and beginning, b for beginning. Now what about writing the equation? They're not proportional. If you took this point here and you just divided y divided by x, you'd get 3. This point, you divide y divided by x, you get 7/4. That's not right. You have to get the same relationship for every point. So you can't just take the coordinates and divide them and say, oh, hey, that's the slope, that's y over x, because it's not. This is not a proportional relationship. It doesn't go through 0, 0. If you double the time, you do not double. If you double the time here from 2 hours to 4 hours, the amount of snow written, the coordinates do not double. So the y value, the inches of snow, does not double because you have to add these 5 inches on in the beginning. So it's not a proportional relationship anymore. So this is just zooming in to this part right here. So I'm looking at this point 2, 6 and this point 4, 7. I'm going to zoom in and go through writing the slope of this line. So you have to find what the vertical change is and divide that by the horizontal change. So the vertical change, remember, you get that from where does this triangle, you can look at this as a slope triangle, where does it start? It starts at 6. Where does it end? It ends at 7. So to get that change, you have to take the ending amount, 7, and subtract that 6, the beginning amount. So what are you doing? You're sliding this triangle down 6 units to the horizontal axis. Or you can look at it as I'm subtracting 6, the beginning, from the end. 7 minus 6 is 1 unit. So this change right here is 1 unit. And what's the change in the horizontal direction? This point right here starts at 2 and it ends at 4. Remember, this point right here is out 4 units and up 2 units. So this is 4 units and up 6 units. So this is 4, 6 right here. So it starts at 2, ends at 4. To get that change, you take the 4 units, which is where it ends, right here or right here, and you subtract the 2 units. So 4 minus 2, so that change is 1 unit, 2 units. So 4 minus 2 is 2. So what's that ratio? The vertical change divided by the horizontal change is 1/2. That is equal to the slope. So this is not that bad. If you just get used to thinking about what's the beginning amount, subtract that from the ending amount. What's the beginning amount? Subtract that from the ending amount. You'll be able to get to the slope. That's one part of the equation. That's the m in the equation. So now we know that y is equal to 1/2 x, y equals mx plus how much? Well, they give that to you. They tell you that that's 5. So you can just write y equals 1/2 x plus 5. Y equals mx plus 5. But for one last time, actually it's not one last time, but once again, how do you get this equation? Now they don't go through this in the summary and they don't expect you to go through this, but it's always a good time to continue to review what you've learned in the past. So you're going to need it in the future. This is where we're going. So what's the slope? We already know is 1/2. Now you have to figure out the y and the x part of the equation, the left side of the equation. So I'm going to call this point, instead of 4, 7, I'm going to call it xy. So how do you get this change in y? Well, you subtract these 6 units. So this is x minus 6. So where does this 6 come from? It's this coordinate right here. This is 6 units. This is also 6 units. So this, yeah, that's right. So this is y minus this 6 right here. So it's as if you're sliding this down 6 units. So that y minus 6 is this y right here minus 6. Remember, before it was 7 minus 6 to get the slope. And then that is over, that's divided by the horizontal change, which is x. So this is where you end up. This is the x value, which for this coordinate was 4, but now we're calling it x. And you have to subtract the beginning amount, which was 2. So this is x also right here. You subtract that 2. That's sliding this triangle over to the y-axis. So x, both of these are the same, x. So x minus 2. So y minus 6 divided by x minus 2, what does that equal? That equals the slope. Y over x equals k, or the change in the vertical change divided by the horizontal change is equal to the slope, 1/2. Right, so now we can write this equation. That's telling you that y minus 6 is 1/2 the amount of x minus 2. So y minus 6 is equal to 1/2 the amount of x minus 2. So y minus 6 equals, if you have 1/2 of an x minus 2, that means you have 1/2 of an x minus 1/2 of 2. Well, 1/2 of 2 that's pretty easy. That's 1. You have $2, take half of them, that's 1. This is y minus 6 equals 1/2 x minus 1. All right, so if you subtracted this 6, you have to add that 6 back. So y minus 6, you have to add the 6 back, so that's y plus 6. Add the 6 over here, but you also at the same time have to subtract this 1, so you're left with y equals 1/2 x plus 5. So that's just a little review of how you write the equation. Just go through that again. Do it on your own. Check it. That'll be a good review.